There it goes, thank you. So I had 4m squared minus 8m. What number can come out? 4. And the way you think about it is, what's the biggest number that both of these have in it? 4. And then what letter can come out, or how many letters? 1m. Yeah, 1m. And that little tiny thing I told you was to move it over here. So you can put this result there and this result there. It's just easier to track. Yeah, exactly. 4's out. I had 2 m's. I took 1, so I got 1 left. 8 divided by 4 is 2, and I took his only m. Aw. And then how can you always check this? Just multiply it back in and see if it comes out. That's how you check that, for example, right? Multiply it out, make sure it becomes what it was to begin with. Kick ass. Not too bad. Alright, so that's the basic idea. We did several yesterday, so I just want to get to the next level here. If I gave you this, let me amp it up a little bit. Let's see if you guys can handle this. So you still do the same thing. It's just that now, whenever you see an expression in parentheses, you consider that to be one thing. Yes, ma'am?
3y minus 6 and m plus 2.
Okay. That's not too bad. There's one little thing not quite right about it. I agree that these both have an m plus 2 in it, right? So I can completely take an m plus 2 out because they each have 1. But what else do they each have?
3.
Yeah, they each have a 3.
Oh.
So what would be left if I take a 3 and an m plus 2 out of the first guy?
1.
A y. And what's left of the second guy?
2.
6 divided by 3 is 2. And I took his m plus 2 away, poor little dude. If you multiply this back in, you get 3 times y times m plus 2. 3 times 2 is 6 times m plus 2. There it is. How are you guys doing this? There's really no difference between what we did here and what we did here at all. Maybe. Yes, ma'am.
Can we multiply 3m, 3 with the m out? It's got to be 3m plus 6.
This is all about factoring. So if you multiply 3 times 3 and you said the answer was 2 times 9, you're not right because it's not completely factored. So you don't want to have the 3 inside here. Then it's not really all the way factored. Maybe.
So how do you get the numbers on the outside instead of them being on the inside?
How do you mean? Are you asking about a different kind of problem or this problem?
That part.
Okay, what about?
Like, if you're multiplying in, how come the 3 isn't on the inside of where this is?
Why isn't the 3 here?
Yeah. Like after, when you get the answer.
So here's the answer.
Yeah.
Now you're talking about when you check it.
Yes.
You're talking about if you multiply it back in.
Yeah.
Okay, so what would happen if I multiply it? So I'm going to take this times y to check it, right? So now I'm just going to check it. What is this times y? Over 3y m plus 2, is that cool?
Yeah, that's where I'm getting lost there. How come it's not like 3y in
3ym.
or ny? You get what I'm saying?
Oh, well, I mean, I could then take this 3y and bring it in, right? Is that what you're saying?
Yeah.
But do you see how I don't need to because to check it there? I've already got that piece. It didn't start off completely inside, right? I like it. And then, of course, to keep checking it, I can multiply that by that. Negative 2 times 3 is negative 6m plus 2. And I got the same thing. Now, if I gave you this problem and I said multiply it out completely, then you're not done here, are you? But all I'm doing is checking to see if this is the same as this. Right? So I don't want to go too far so that I miss that. Yeah, that's the same thing. I like it, maybe. So what you're thinking about is this. Here's where we left off yesterday. Just got a problem here. Let's see. So really, what always happens, you always try GCF first. You look at all the terms and see if something comes out. That's what I call step 0. It's always there. Then you say, okay, how many terms do I have? Yes, ma'am.
I know one number that I can pull out of, like,
But it can't come out of most of it. It's got to come out of all of it to be a GCF. Will anything come out of each of these terms?
2.
No. I keep pointing at things there's no y here, so how could you take a y out? There's no number here. How could you take a 2 out? There's not a damn thing that comes out of everything, right? You're fine. Don't worry. You're fine. It won't always have a GCF. So GCF is not always going to be something you can do, but it's always the first thing you check. I like it. Because sometimes it's the only damn thing you can do. You do it, you're done. Yay. But sometimes you'll do it, and there's more to do. But you always do that first. Get that out of the way. So there's no GCF. He's got no numbers. He's got no Y's. Nothing can come out of everything. So, but there's 4 terms. So remembers what I could do. There's a process I could use since there's 4 terms. Grouping. So if you look at the first 2 and the last 2, now you can sort of do it like you were trying to do, Morgan. Now you only have to take something out of these 2. And something out of those 2. So what comes out of these 2?
2? Oh, 4.
4. Is that good? And what comes out of these 2? Y. So you have plus is still there, right? Plus y comes out. What's left? Y minus 2a. So how do I know I'm on the right track? What looks good? What looks like it's supposed to look like right now? Why was I able to do anything here? Because the n plus 2's were the same, right? If these weren't the same, then I could never have taken the n plus 2 out. So what's the same here in both of these terms? Y minus 2a. They each have a y minus 2a. So I can take a y minus 2a out. So what's left here if I take a y minus 2a away? Out. 4. Plus, what's left over there? Y. I know I wrote that really big, but just wanted them with their parts. So sure enough, when you multiply y minus 2a times 4 is this, and then if you multiply that in, you get back to the beginning. And then this times this is there, which leads to there. Yes, sir?
So the answer is 4 plus y.
Well, the answer is y minus 2a times 4 plus y. The answer always has to be something that would multiply out to be this. So you can't lose any parts. Right? Just like up here, the answer is 2 times 3 times 3. But I'll sometimes have students say it's 3 times 3 because they just see this and they forgot to pull, does 3 times 3 equal 18? Oh shit, no. I forgot the 2. So you don't want to lose anything because the final answer has to be the same as what it started off as, just broken up into parts. Maybe. So this process here is the exact same process here, believe it or not. This just looks a lot worse. Why? Because there's a whole bunch of freaking numbers in it that I don't know. So of course it's going to be a little harder. Okay. Are you guys... this step is the one that I'm always curious if students can really, really see it correctly, because there's just so much going on there. So right here, if I wrote 4b plus yb, how do you factor that? No tricks, come on. Yeah, what comes out of both? B, and you're left with? What if I would have said For W plus YW. Ooh, that would be so... No, it's the same damn thing, right? Because they both have a W. So W will come out, and then I put 4 plus Y. Is everybody cool with that? So what if I put 4 times something plus Y times that same thing? Well, whatever that same thing is, it's going to come out. Even if I make it something like Y minus 2A. Here, a B came out because they both have a B. A W came out because they both have a W. A Y minus 2A comes out because they both have a Y minus 2A. And that's a hard step to take as a student if you're not used to looking at it. But this is just one stupid little number. So it's going to act the same thing as this one stupid little number would act. I like it. So that's why that. Take that out. You're left with 4 plus Y. All right, you guys try this one. All right, Jeff, let's see if you can make one that works. Yes, that would be so nice. Factor that bad boy. All right, guys, let me catch up to you. Is there anything that goes into all 4 terms? Not a damn thing, right? This poor little dude's got no C's and D's, and oh well, this is prime, and the 5 doesn't go in. All right, nothing goes into all 4 things, but there are 4 things, so I can look at it like this. I can try this. Now, one thing I want you to realize, I don't know if anybody's thinking that's not always going to work. Of course not. And of course, the problems that we're doing right now are kind of made to work. So on one level, you're like, well, then only the problems that you force to work this way are going to work this way, Jeff. What kind of bullshit is this? But you would be amazed at how many times problems come out of just natural stuff that we do, and then look at the math, that come out factorable. And also, there's a lot of processes in math that we base on the idea of factoring. So factoring, to me, is a fundamental skill in mathematics. All right. All right, just deal with that. So what comes out of these 2? 2.
1 and 2.
And what comes out of these 2? C.
5 2A.
2A. Yeah, I see. So real quick, if these 2 are not the same, then either you made a mistake, or maybe something's got to switch. They gave it to you out of order. Right? You might have to sometimes switch the middle terms to make it work. So those are the things you look for. What's the last step here? Why do I know I can do the next step? Yes? these two are the same. If they are not the same, do not do another step. Right? I always get somebody that gets like 4x plus y minus 2x minus 4y, and they just try to put 4 minus 2x plus y, they just put everything, they just put it all down there and then just pray. No, it's crap. You can't do the next step unless these are the same. Because the next step is, if I have anything the same, I can take it out. So what do I take out? 5b minus 2a, and I'll be left with 2 plus c. Secants. So if I check, this times this is there, this times this is there, and then these would become those. I mean, that's beautiful. You can see the dominoes falling back. I like it. Alright, so let me give you one more here. See how you handle it. It's got something that we haven't seen yet. You're not even going to realize it at first. Alright, let me make it work. Find out how that works. I don't know if you guys can see this. There's actually a major difference between that and this. Hopefully the major difference is this one doesn't work. Let's see. Looks like it should work. Yeah.
So you split it up.
Oh, wait, sorry. Give everybody a second to do it. I thought you were going to ask a good question. Yes, ma'am.
Sometimes you have to switch to middle terms in order for it to work.
Yep.
You switch to outside terms.
Yeah, actually, yeah. Sometimes most often the textbooks will make the middle terms out of order, but it could be anything that. And there are multiple ways that would work if it works. Just kind of, if I switch these two, for example, this would still work. But if I move that there, maybe it won't work anymore. I like it. All right, Morgan, hit me with it.
So the first part is 4x, and then parentheses xy plus 3, and then negative 5y.
Good. All right, so notice these are both negative. So here's the thing I haven't said yet. I keep saying that these have to be the same to do the next step. So that actually helps you do the problem. I want the thing in here to be the same as that. If I don't change these signs, there's no way it can be the same, right? So I've got to take a negative out. And of course then I just see they both have a 5, they both have a y. So if I take a negative out, what's going to happen to both of these signs? They'll become positive, right? So what's left here? Negative 5 and y is gone. So what's left? xy plus 3. So are these the same? Yes. So that negative in the middle always screws people over. In fact, some teachers teach that you put parentheses here. Oh my God, that sucks so bad. If I put parentheses here, I took a negative out, I got to remember to change that sign. Holy shit, why do that to yourself? So I'm like, don't put freaking parentheses, just underline the damn things. And if there's a negative here, you take a negative out. I don't know, to me that just is better than having to remember, oh shit, I'm supposed to change the sign, whatever. No, screw that. So what's that last step here?
X, y plus 3, and then 4x minus 5y.
Now, if you put this, is it the same thing?
Yeah.
Because if you tell me that 5 times 7 is not the same as 7 times 5, I'm going to look at you funny for a little while. So, of course, this number times that number is the same as that number times this number. So it doesn't matter which way you put the factors at the end. Yes, sir?
If we take the first term with the third one, take xy.
All right, let's see. So if you switch these around, let's see if you get the same answer. So if you put, are you saying to change this to be here?
Yeah.
And of course, what's nice if you do that, the middle term is positive, right? So that kind of takes away that negative problem. Let's see if it still works. What comes out of these?
xy.
XY.
4x. Minus 1.
All right, is everybody cool with that? Take an X out, take a Y out. So he's got, lost his Y, has one X. He lost his X, has one Y. And then what comes out of these two?
3.
That's pretty easy to see. So notice this, it's kind of cool. Where's the 4x minus 5y on this step? On the outside. Where's the 4x minus 5y on this step? On the inside. But notice how at the end, it comes back together. What do you put at the end here? 4x minus 5y? xy plus 3. Same answer we got here, of course, right? Sort of related to if you factor 18 and you start with 2 and 9, or you start with 3 and 6, you're still going to end up at the same place. So there's multiple ways to kind of start these problems off. Okay, how we doing? That'd be not too bad. So you got GCF, and then you got grouping, which is sort of repeated GCF, right? So they're both based on the idea of taking out the biggest thing you can. You gotta like them. You don't have to, but you should. Okay. Any other questions on that, on the grouping thing? I don't think it gets too freakadelic in here. Let me take one out of the homework, see if they got anything weird. Not really. Yeah, they got, actually the ones they have in the book are easier than the ones we were just doing. You gotta like that. All right. So there's, you guys want to do one more of those, or you ready to go to the next step? How you feel? One more. Okay. All right. Let me give you a slightly different one. Let's see. Sure. All right, try to do that one there. going to do this one two different ways. How did somebody start this off? Anybody?
Split into two.
Good idea. Did anybody start it off a different way?
I just took out
I like it. All right, so there's two ways to do this. One way is to go ahead and start grouping, so I'll do that way first. And the second way is to kind of go by the book and say, I always look for GCF first, and sure enough, they all four have something you can take out. So let's do it this way first, and then we'll do it the other way second, and I'll show you they both come out the same way. Again, it's sort of like saying 18 is 3 times 6, and so, no, it ain't 2 times 9. What the hell? So if I start this way, what comes out of both of these guys? Yeah, 2, x squared, a. Yeah, I'm kind of going against my own thing. Let me solve some root. 2, x squared, a. And what's left? 3, x. Good, minus 2. Because you took the x squared a out. I like it. That looks nice so far. And what comes out of these two, noticing that's a minus sign, right? So, now watch this. It's kind of cool. You want a 3 here. So what are you going to take out of there? 4. And you want an x, so you got to take an a. So thankfully a 4a comes out of both of those. Do you see how I'm using this guy to help me get this guy? Sure enough, negative 12 divided by negative 4 is 3. Make it 3, Jeff. Hey. X, I like it because the a's gone. Minus 2. So then you end up with, on the next step, there's one more step after this, believe it or not. You have 3x minus 2, they both have a 3x minus 2. So why would I take points off if you stopped here right now? Because you're a jackass. No. Why would I take points off?
Then you still take 2.
Yeah, you're not done factoring yet, right? You're done factoring yet. You got stuff that can come out of here. What can come out of here? The 2a that you could have taken out in the first place. So it's like you take the 2a out first, or you take the 2a out last. The problem don't really care. So I can take let me see if you guys can handle this. I don't want to put the 2a in the middle. That looks freaky. So I'm just going to put the 2a that I'm going to take out here. What's left now if I take a 2a out? X squared. Minus 2. I like it. And now I know I'm done because none of these parts have anything more I can do with them. So I know I'm done. So the other way you could have done this is to take a 2a out first, and then you would have had 3x cubed minus 2x squared minus 6x plus 4a. No, plus 4, thank you. Now, I want to show you this way. We know it's going to come out to be the same answer. I mean, hopefully it's kind of obvious it's going to come out to be the same answer. But how do you handle this dude? Well, he just comes for the ride. He's done. So he's just coming for the ride, and he's waiting for this guy to get himself done. What's out of these two? What comes out of those? X squared. And left with 3x minus 2. That sounds familiar. What comes out of these two? It's got to be a negative 2. So that becomes positive 3. That becomes negative 2, right? 4 divided by negative 2 is negative 2. This guy, still coming for the ride. What comes out? 3x minus 2. And what's left? X squared minus 2. Same thing, thank God. I like it. So the 2a is in there. It doesn't matter if you take it out first or you take it out last. It's in there. It's going to come out eventually. It's got to. The nice thing is if you take it out of the way first, you ain't got so much crap to look at on the next step. Right? You got to decrease the crap. So that's why GCF is a good first step always. Okay. So we got this here. So let me ask you, just as a stepping stone for the next level of factoring. There's a lot in this section 4.2, by the way. It's got all the factoring. It's crazy. Let me ask you a weird kind of question. You find two numbers